So we're going to start up this morning. It's Lianna Vice, who was a PhD student with us and also employed by the Ontario Geological Survey, is going to talk about our work in the Michipicoten.
All right, good morning. And yeah, thanks Ross for the intro. So I'm just gonna get started right away talking about my work out in the Michipicoten. So as Ross mentioned, this is a joint project between the Ontario Geological Survey and Laurentian, and I'm Supervisor under Stefan. So a quick outline of what I'm gonna be talking about today. I know I was here last year, so I'm only gonna do a brief background, and then I'm just gonna go into the research objectives that we'll be looking at for today's presentation, and then some preliminary results, and then some of the working hypotheses from these preliminary results and the next steps. So the Michipicoten Greenstone Belt is located just northeast of Wawa, Ontario. It is best known for the currently producing Island Gold Mine and Magino Mine, as well as the past producing Renabi Gold Mine. There's been active exploration in the area with some very significant discoveries recently. Getting into the architecture of the belt, so it's a classic granite greenstone belt of the Superior Province, and it was separated into three different volcanic cycles, which are overlain by the Dore metasedimentary rocks previously. So the work that was done with the volcanic assemblages in the belt previously was primarily focused on this western part of the belt and the mapping, and there was not really mapping from the eastern part of the belt compiled into this, which is, it's not flipping, there. Brings me to our study area, which is in the eastern part of the belt. So this belt was not included. And so this is something that the OGS has been working on for about 10 years now, with mapping in this eastern part of the belt, and I've been able to wrap into my PhD study. So objective of today's talk is I'm going to be looking at, this is primarily geochronology today, and how it is able to update the supracrustal assemblages in the eastern Michipicoten Greenstone Belt. So questions we're asking are, what are they? How do they compare with adjacent belts and subprovinces? And then what are the implications for continental growth in the Superior Province? So methods we've used, bedrock mapping, obviously. I've worked for the survey, so that's the primary part of every project we're doing. I have a considerable amount of geochronological data that I'll be presenting today. I'm just going to forward you that I put most of the geochron together in the last 2 to 3 weeks. So it is preliminary and it is subject to change based on once I have a time to get through the trace element data as well. Just because, but I have, I've been able to put it together for today. And then afterwards, going to be working on whole rock and trace element analysis with it. So this lithological map is the most recent version of the geology in the area from my regional mapping. And this version was released in our 2024 Summary of Fieldwork. So a significant starting point to the inspiration of this project was looking at the geochron that was coming out of the 2013 to 2018 mapping with supracrustal ages primarily done using TIMS, which were coming back at 2740 to 2695, which were a little different than what was previously interpreted from the mapping in the 70s to 90s. And then intrusive ages coming back 2741 to 2661. So this is just a spatial of the sampling that was done previously in the area. And then I'm going to, next slide, is showing now our current sampling that we've been doing over the belt to try to get a better handle on what some of the assemblages. So what I'm shown here is, this includes in white all the ages we've returned that was never dated before. The black diamonds are ones that we've managed to reanalyze. So these were dated using TIMS, most of them, through the OGS. And in order to get a little bit more information on the spread of the data and whether or not we're having any inheritance, we've also rerun these separates using laser. And then, of course, as we always find with zircons, is sometimes you get skunked. So that's also demonstrated here that we have. It's not some of the assemblages are question marks for now because it wasn't for lack of trying. So yeah, we have 36 samples that we have analyzed and have returned dates. 11 of those being reanalyzed, and then we've got 2 still at ODM for separation. So I'm going to be systematically going through the new ages. By assemblage. I'm not going to be going through one at a time, just for the sake of time today. So with these ages, I've managed to put together, again, a very preliminary assemblage map in the area. There are definitely still some unknowns that will likely or possibly change as I kind of pour through the more of the data. But we can already see is that there's a significant change to what was previously interpreted for this part of the belt, and that there's a little bit more going on in this part of the world than was expected. All right, so I'm going to get into the packages that I've separated them into, just based on the dates. So first one, ages approximately 2730 to 2725. So this comes from 7 dates from metavolcanic units. 2 of these were also rerun from TIMS, and they're very close in error, which is always nice to see. And then we have 1 date from an intrusive rock that seems to be putting a minimum. So within this package, we do have a kind of a west to east compositional change. So out here in the western part of the area, it seems to be more pillow basalts intruded by gabbros, whereas once we go further to the east, we have felsic volcanic rocks, and then across all lithologies there does seem to be iron formation that's kind of worked its way. Sometimes it's at the top, sometimes it's in the middle, and still working on how that kind of fits. Okay, so next we've got 2720 to 2710 million years. So these dates are coming from metavolcanic units mostly, and then we have 1 date from an intrusive rock. I know it's outside of the belt, but since that's the location of Bernabe, I figured it would be of interest. It's come back slightly younger than what was previously dated with TIMS, but it's still within the same package, which I'm pretty happy with. So yeah, with some of the dates in here, the 1 sample, it was, even the old separates, there were so few zircons that we had a very poor, it just wasn't a great laser age. I'm going to see if I can get some more separates. So our old TIMS age still stands though, and it's fits very nicely. So just a mention on this unit, this package. So dominantly, these rocks seem to be intermediate metavolcanic flows with iron formation. And then this part down here, I have put a big old question mark just because we couldn't get zircons back yet. But in terms of the spatial setting and how it's similar to the others, and then and also the stratigraphic setting, it seems like this will be the best guess of what package these rocks down here will fit into. Okay, so next was the 2700 to 2695. We've got 3 dates from metavolcanic units. These rocks are bimodal mafic flows and volcaniclastic rocks. And then this is also the location of probably the only, seems to be VMS-style mineralization that we see in this whole part of the belt in these younger rocks. So the continuity of this age that's on the west side of the Meath Lake Fault is uncertain. So for now, I've just put a little sliver. The age is right, the volcanics are there, but I'm not really sure exactly how they fit in just yet. So that's something I'm gonna have to keep working on. So the last metavolcanic ages we were getting back, I might end up lumping them in with the 2700s, that's to be determined. But these are 4 dates from felsic metavolcanic rocks that were interlayered with termititic rocks, either up here in what we've called the Low Couch Basin, or even along here, this is the Baltimore Deformation Zone, interlayered with the sediments there. So also interlayered with the metasediments up here in the north, we do also have mafic flows, but obviously it was the felsic ones that we got these dates back for. And now I'm going to go into our sediments. So this package seems pretty consistent north and south. We have a larger basin in the north and then little sniffs of sediments that are all throughout the belt, a lot of the times close to deformation zones. We have 8 maximum depositional ages from these turbiditic metasedimentary rocks, and then locally down here, these also appear with iron formation. All right, so our next age, this is pretty much based on the one date from a package of conglomeratic metasedimentary rocks here along the Baltimore Deformation Zone. I also have, it's a youngest statistical population, so I'm not confident yet that it is the age, because you can see I also included that one here. It's the same sample. So I want to look more into whether this youngest statistical population is detrital or if it could be coming from the 2670 intrusion that's just north of it. But we've also got ages from potassium-rich intrusive rocks, possibly alkalic. We have to look at the chemistry on these. That would suggest a local source for the zircons giving us this 2675-ish age. And then just as I mentioned, the conglomeratic rocks that we see in the area, there's not many of them, and they're not very big, but they are localized along these major deformation zones, which I've described in our summary fieldwork this year. So what we've managed to do is put together a very preliminary lithostratigraphy for the area. So I've thrown all of the dates from all of the samples into the packages. What we were hoping for is to see if we could confirm with nice peaks if we do have pulses of volcanism or continuous. But I think based on the error and the Archean nature of our rocks, we can't quite confirm that yet, so that's something I'm still going to be working on and looking at using the trace elements and the lithogeochemistry to try to assist with that age definition. And then I'll be coming back to this figure later. So preliminary lithostratigraphy. So now I'm able to compare our stratigraphy to what was previously interpreted in both the Western Michipicoten as well as what's known in the Abitibi. So it's something that everyone's more familiar with. So I'm just going to go through it. At the end, it'll be a bit of a mess, but we'll get through it. So starting at the top of our section, it's pretty good correlations. We're seeing turbiditic rocks, conglomeratic rocks. Within the Dore, these were the Dore metasediments. These were lumped together, but I'm pretty confident that we're able to pull out our conglomerates from our turbidites in the Eastern Michipicoten. And then, of course, we do have these volcanics that are interlayered. Seems to be near the bottom. And then these do fit nicely with what we know from the Abitibi with the porcupine and Temiskaming assemblages. Next is our 2700, 2695. So these kind of fit at the very tail end of the catfish. So whether or not we are going to be lumpers or splitters, I'm going to figure that out. But it doesn't quite fit with what was previously interpreted over here, but it does fit nicely in terms of timing with what's known in the Blake River. And then coming down, we've got what is our 2720 to 2710. Again, we're kind of on the edge of what was previously interpreted in the Michipicoten in terms of volcanism, so I'm going to have to still riddle that out. And then in terms of ages for the Abitibi, we fit quite nicely in timing-wise with the Kidd-Monroe and potentially, depending on error, with the Stoughton-Rockamore. Again, I'm going to mention that our ages fit nicely, but as you can see, the stratigraphy is rather different, which is something that we really need to keep in mind. Moving down, 2730, 2725. Again, we're in between assemblages in the Michipicoten, but fits nicely in terms of the Deloro assemblage and the Abitibi, but once again, it's a very different lithologies. And then what's not observed within the eastern part of the Michipicoten, but is observed in the west, is the Wawa assemblage of 2750 to 2735, which matches nicely with the Picard. And then, as everybody knows in the Abitibi, we don't have anything so far that was coming back at this much older Hawk assemblage with the 2890 and older. So I'm going to also get back to that later. So the next slide's a bit of a mess because it's all of those things you've just seen piled on top of one another. And this is, I just want to be able to show it to really highlight the differences in the stratigraphy in this part of the belt with the rest of the Michipicoten, as well as the Abitibi. So differences with Michipicoten itself is we seem to be splitting our assemblages. So either we are our ages are in between, and we have many more assemblages in the Michipicoten than was previously interpreted, or I'm going to end up lumping them together, which is something I'll be working on. And then again, what we don't have is volcanic rocks of the Hawk assemblage in the east. What we seem to be missing from the Abitibi is these Tisdale-aged rocks. We have Tisdale-aged zircons, but they're not coming out as like a strong population. They kind of seem to be in between. And then in the eastern Michipicoten, we also do not have the Picard. Something that is notable, especially in the younger rocks in the Michipicoten, is that we do not have the presence of ultramafic metavolcanic rocks. There are ultramafic intrusions, but those are different. And the ultramafic metavolcanics in the Michipicoten were all seen in the older Hawk assemblage rocks. All right, so I told you I was coming back to our Hawk assemblage and the Mesoarchean zircon. So although we do not have any volcanic rocks in this part of the belt that are coming back as being Mesoarchean, we do have sniffs of Mesoarchean zircon that are within many of our samples. So that's the ones I've circled here in red. All these samples have come back with some in the presence of greater than 2,800 million-year-old zircons, within like concordant zircons. So something that you can note is that a lot of these black diamonds, which were the ones we reran from Tim's, I haven't gotten as many Mesoarchean zircons in these, and I think I just need to look a little bit more at the separates, which I've had that conversation with Mike already, to see if I can pull out some of the uglier zircons from those nice Tim separates to see if it's a methods thing or if it's the fact that we don't have that inheritance. All right, so looking at the Mesoarchean zircon, so here's the presence you can see in both their metavolcanic and metasedimentary units. I've obviously exaggerated the scale so you can actually see it, because these are all of them lumped into one histogram. And you can see presence in both the metavolcanic and metasedimentary. The interesting thing that we do notice is that the oldest we're seeing in the metavolcanics is older than the oldest we're seeing in the metasediments. And it's also even the volume, it seems to be greater in the metavolcanics. So I think something that we can interpret from that is possibly that the metaseds are being sourced from our metavolcanic rocks. So some future work that I'm gonna wanna do on these rocks is hafnium isotopes. And so I'm currently assessing the feasibility of this to get on the laser in the spring to compare these old versus these young zircons. I think the issue that I have is the size of zircon, so that is something I'm really going to have to look at, because obviously with hafnium you need a much bigger grain, and some of my grains are pretty small. So we want to test whether we have non-juvenile volcanic rocks or juvenile volcanic rocks with these deep crustal contamination during ascent. All right, so another working hypothesis and implications that we can take so far from our geochron is looking into these metasedimentary rocks and trying to get a provenance on them. So when we're stacking these, we don't see your typical nice same peak in the sediments that we see in the volcanics. What we do see is this weird reversed peak. And then also the sediments, they line up with the intrusives, but it's also, again, not like a perfect cut and dry, like, boom, this is coming from that. So it's something that we're going to have to do some more interpretations on. So some hypotheses that are working and that we can continue to work on would be, first, that the metasediments in the area are coming from a local provenance. So we can either, one that seems to make more sense would be coming from primarily metavolcanic units. However, this difference in peak seems to be, it doesn't quite match. So what we can, if the metavolcanic rocks were the primary source, what we can interpret from this very, very large peak at 2700 is that a lot of these metavolcanics that were at the 2700 age have since been eroded into the basin. This seems to be a pretty clean story. It means there's been a lot of erosion in the area since volcanism. Another possible source would still be a local provenance, which still fits in terms of ages, would be coming from primarily intrusive rocks. The issue that we see with it being primarily intrusive is just the sheer volume of these synvolcanic intrusions. They're not as big and just don't take up the same volume that all the metavolcanics do in the area. So it seems to be that the volcanics would be more likely, but the intrusives are still possible. And then we have also a possibility of exotic provenance. It is possible, but I think based on the patterns we're seeing, this would also be, we consider it to be unlikely. And then especially when we combine that with the presence of these Mesoarchean zircons, which we know are part of the Hawk assemblage. So yeah, our working hypothesis and our so far is that we're mostly taking from the metavolcanic rocks, and that would mean that the volume of greenstone may have been much larger in the past than what we see now. So yeah, just getting summary of today. The talk today, Eastern Michipicoten Greenstone Belt can be separated into at least 3 metavolcanic assemblages and 2 metasedimentary packages. These assemblages differ from what was previously interpreted for the Michipicoten stratigraphy. They align in terms of timing with much of the Abitibi volcanism, but they have very different lithological characteristics, putting them in a slightly different setting. The Mesoarchean zircon, both inherited and detrital, suggests this presence of older and thicker crustal substrate. And then the most likely provenance that we are currently working with will be provenance from metasedimentary packages is coming from locally sourced metavolcanic rocks.